Okay, here we go with a sort of bonus video for Trig sub. I'm going to give you a bunch of examples of how we change thetas back into x's after we're done with our integrals, because this is something that trips people up a lot of the time. So what these examples are going to be is, suppose you had some integral you wanted to do with Trig sub. I don't know what it is. I don't know what the integral is, but suppose you had an integral that you did with Trig sub. You made this substitution, and this is the answer that you got. What we're going to do is just the last step of the problem. How do I change all of these back to x's? So I'm going to give you 3 examples. Pause the video as always and try it first. Okay, let's start with the first one. I'm going to take this here and just copy it so I can have a lot more room. Oops, that is the wrong one. Let me just move it down there. Perfect. So if x is sine theta, I always have to draw a triangle to figure out all the other trig functions. So theta, I have to isolate the trig function. Theta, I always have to write as a sine theta has to be a fraction, because sine is opposite over hypotenuse. So x is just x over 1. So that's going to become opposite over hypotenuse. Pythagorean theorem gives me square root of 1 minus x squared. You can check that if you want. And then all of the other trig functions I can now do. That's going to be ln absolute value. Secant is 1 over cosine, which is 1, that's hypotenuse over adjacent. So I get hypotenuse and adjacent, minus, keep my third out front, I got to do tangent. That's opposite over adjacent. And at that point you can leave it there. I think that's good. Let's do the second example. I'll move that one down. Okay, so every single time I gotta draw out a triangle, and I have to isolate the trig function because I gotta write it as a fraction. So tan theta is gonna be x over 3, and here's my opposite and adjacent. Opposite and adjacent. Oops, I should just write them. X and 3. Check this on your own, you'll get as the last side. X squared plus 9. Now I can just do the rest of it. 1 over root 2. ln cosecant is 1 over sine, because they're backwards with the first letter. 1 over sine, so it's not opposite over hypotenuse, it's hypotenuse over opposite. So here's hypotenuse over opposite. There's cosecant. I got to do cotangent. That's tangent is opposite over adjacent, so now I got to do adjacent over opposite. Okay. Plus 4, cotangent. Cotangent I just did. It's adjacent over opposite. Minus, and theta I don't have on my triangle. Sorry, I should have labeled it. Theta's right here. Theta I don't have on my triangle. I only have the trig functions of theta. So I got to go back in my substitution and solve for it. So if x is 3 tan theta, then tan theta is x over 3, and then theta is arctan of that. So my theta, I can just copy it. Arctan x over 3, and that's it. I'll go ahead and copy number 3. Oops, shoot. Seriously? This is helpful. At this point, I should have just rewritten it, but there we go. So picked a tricky one here. So as always, I gotta do my triangle. I'll label where theta is. And I gotta isolate the trig function because I need it as a fraction. So secant theta is x minus 4 over root 2. So secant is hypotenuse over adjacent. So I got hypotenuse over adjacent. Now I gotta find the other side. This one I can't do in my head, so I'll just do it on its own. I have root 2 squared plus b squared is the hypotenuse squared. So 2 plus b squared is, I'll FOIL that, minus 8x plus 16. And then b squared is, I'll subtract 2. And b will be the square root of that. So there's my last side. It's the square root of x squared minus 8x plus 14. Okay, so I've got two problems here. I have theta drawn here, but I don't know what it is on the triangle. I only have the trig functions. So theta, I got to go back here. So theta from this line, I can just take the inverse secant of both sides. Arc secant of x minus 4 over root 2. So there's my theta. Arc secant of x minus 4 over root 2. Now I got to do sine of 2 theta. But I don't have that on my triangle. I don't have 2 theta. So I got to turn that into a trig identity. That'll be 2 sine theta cosine theta. And in fact, for now, I'll just leave that. I'll also erase my Pythagorean theorem work. And I'll do the rest of it. Cosecant is 1 over sine, which is hypotenuse over opposite. And then plus a quarter tangent to the fourth. What's tangent? It's opposite x squared minus 8x plus 14 over adjacent root 2 squared. I'm sorry, to the fourth, because it's tangent to the fourth. I'm running out of room there. So now I'll plug in the rest of it. It'll be arc secant x minus 4 over root 2 times 2 sine theta is opposite over hypotenuse. Square root of x squared minus 8x plus 14. That's opposite over hypotenuse. Cosine. It's adjacent. Sorry, it's opposite over hypotenuse. I did opposite over adjacent. Over hypotenuse. Times adjacent over hypotenuse. Okay, and then I'll just recopy the rest of it. Minus all of this. And then plus all the rest of it. I guess, I don't think it's necessary, but you could distribute this fourth power. Fourth power under a square root. That's something to the 1/2 to the fourth, which is squared. So I could do that quadratic squared over 2 squared, which is 4, and then turn that into a 16, but not super necessary. Other than that, I guess I could multiply this out, but from there I think it's perfect. I hope this video helped.